Good afternoon, everybody. How are you guys doing?
Good.
Very good. So today, we're going to talk about iRVision. And we're going to talk about how we can set up an inspection vision process. Alright? Inspection vision process, which is one of the applications of the iRVision. As you remember, there are two different types of cameras, right? One is mounted on the robotic arms, and one is fixed, basically. So the camera that we have here is fixed, as you can see, right? So it's just sit there, and it doesn't move with the camera, right? So with the inspection vision process is basically a very cost-effective approach to check the part, to see if the part is right or wrong, if it's the right part or if it's the wrong part, right? Or check the orientation or verify critical features of a part, right? So basically, instead of, QA human checking the part, you can have the system check the part, right? For you to see if it passed the part or if it fails the part, or if you can determine the part if it's correct or not, right? Now, for that, it doesn't need any calibration because it's just basically pass or fail, right? You don't need to calibrate anything. You just take a picture and check the part, right? See if it's correct or wrong, right? Now, and obviously, it cannot be used to modify robot movement, right? Because sometimes you use the camera to modify the robot movement. If the part is there, the robot moves there, right? If the part is here, the robot basically modifies the robot movement. But with the inspection vision process, it basically pass or fail, right? Either pass the part or fail the part, right? Now, the overview of this system, the very first thing you need to do is to set up the scale conversion. And we're going to use that with this grid, all right, with this provided grid. And what that does, you're going to teach the system to be able to have a sense of distances in the space, right? Otherwise, how does the system knows from here to here is how many millimeters, right? So the very first thing you're going to teach the system about the distances, and that's what they use to train the system, the vision system, right? So, for example, the distance between each dot to the next dot is 30 millimeters, right? So you put that in the system so it knows that, okay, that's 30 millimeters, for example, right? So that's the very first thing in order to do an inspection vision process, right? The second thing, you're going to train the geometry of the part, right? And we're going to do that using the GPM, which is geometric pattern match. So, for example, you're going to teach the system about the geometry of any part, for example, this part, right? To look for the geometry, right? And the next thing, you're going to teach the vision system to do some measurement. Not only look for the geometry, but look for some measurement. For example, the length of this edge, right? To make sure that's the right length, for example, right? Not only the geometry is correct, but also the length is correct as well, right? That's the third thing that you're going to teach the system. And finally, you're going to do the overall inspection of the part based on that GPM, the geometry of the part, and that edge measurements, right? And based on that length that does measurements, right? So there's a 4-step process to do this inspection vision process overall, right? So can you tell me what's the first step to do?
Scale.
Scale, right? How do we do that? Using this grid, right? Now, what's the next step? Geometric pattern match, right? To teach the geometry of the part that you want to inspect, right? Because the camera have to, be trained to look for certain features on the part, right? The geometry of the part. The next thing is
Edge measurement.
Edge measurement, exactly. Not only look for the geometry, but also, let's say I want to make sure that this edge is within particular distance, like from, 9 to 11 millimeters. If it's not, fail the part. If it's good, pass the part, something like that, right? And the last step is just inspect the part, right? Put some criteria and inspect the part, either pass, fail, or undetermined based on that criteria, right? So what I'm gonna do, through some series of screenshots that I took from our teach panel, I'm gonna teach you step through the process, all right? Now the good thing is that the iRVision system has its own menu, basically, right? So all you're gonna do, press menu, and then number 8 is the iRVision, right? You know that you have utilities, you have I/O, you have setup, you have file. Then number 8 is the iRVision, right? So once you press iRVision, it goes to this screen, and here you press V type. So that's the vision type that you want to set up, right? So you're going to select the vision process tools because you have some options here. The very first one is a camera setup. So that's the very first thing you do to set up your camera. Our camera is already set up, so you don't have to worry about the first one. The second one is the camera calibration. For this system, we don't need to calibrate anything. So I'm going to go to the third one, which is the vision process, right? I'm going to create a vision process tool, right? So select that, and once you do that, then you're going to press create, right? You're going to create a vision process, right? So press create to create a new vision process, all right? Now this screen opens up after that, and then you have this drop-down menu. You can basically create different vision process. What we're going to use is the single view inspection vision process, all right? So it's all the way at the end of this drop-down. So the single view inspection vision process, you're going to select that. You give it a name. I'm going to call it inspection. If you want, you can put a comment, but you don't have to. So we're going to create a single view inspection vision process under the name of inspection. And then once you do that, you're going to press OK, right? You're going to press OK, and then there you go. You just created an inspection vision process, but you're going to set it up now, right? You just create a name. Now I have to go and edit it, right? To train it, to teach the system, right? So you press edit. You press edit, and then this screen opens up. The very first thing we do is what? To basically do the scale conversion, right? So there are two tabs here. One is image and one is the tree. And we're going to go back and forth to be able to complete this vision process, all right? So first, on the right side, camera setup. So you're going to select a camera. What camera am I going to use to do this iRVision, to do this vision process, right? And once your camera is already set up, you just do this drop-down menu, and you're going to select the camera. In our case, it's Cam 1. So the name of this camera that we have is called Cam 1, right? Camera 1. So that's the camera, because sometimes you might have multiple cameras, right? Which camera are you going to use to do this vision process inspection, right? So select the camera. Then there are some specs here. Leave it basically to default. For example, exposure time. That's the exposure time to take the picture, right? For the camera to take the picture. By default, it's 33.33 milliseconds. And that's good. It depends on the brightness or darkness of the environment. You have to change that exposure time. But by default, it's 33.33, which will leave it like that. All right. The next thing, once you select the camera, then you can go live. If you press live, it shows whatever the camera sees, right? So what you're gonna do, you're gonna put the grid, put a vision grid under the camera, and then press snap, right? That's F3. So if you press snap, it takes a picture of that grid, right? Which shows right here. And as you can see, it basically takes a picture of whatever the camera sees, which is more than just this vision, the grid, right? It sees some other items also, but you're gonna be able to modify it later on. So once it takes a picture, you're gonna put the grid spacing, right? Here, there is a place that says, what is the distance between these dots, right? That's how you train it, right? In this case, the grid says it's 30 millimeters, right? It says actually right here, 30 millimeters. So you're gonna put 30 millimeters, and then after that, you're gonna put the focal distance of the lens of your camera. So our camera is the Sony XC56, and if you look at the specs of the camera, it tells you what is the focal distance of the lens. So it's 6 millimeters, so you put 6 millimeters here, all right? And then, one last thing, the height from the plane. So the part that you wanna look at or inspect, what is the height of that part? For example, if you're using this domino, what is the height of this domino? Because if I'm looking at this part, if it's the height, it depends on how far from the eye of the camera or from the lens of the camera is, right? So you're gonna give it that height, right? So because the height is different from the plane of this vision process, right? Or this vision grid, right? So our height here, I would say about 7-8 millimeters. So I put 7.5 millimeters right here, all right? And based on that, it basically, once you press train, so I said 30 millimeters here, 6 millimeters here, 7.5, and you press train, right? To do that scale. So it shows what the camera sees, and then I'm gonna basically adjust the box. As you can see there is a box on the field of view. It adjusts the box to include only the grid, basically circles, right? Because this is what I want to look at, right? To train that scale, right? I don't care about this area, right? So you're gonna fit that grid, and then you're gonna press OK, right? So you press OK, and then basically it says the scaling data has been calculated. You press OK, and bingo. Now it shows you the scale conversion, which is 0.887. Usually it's under 1. Most of the time it's under 1 actually, all the time. So we're good. So 0.887, that is our scale conversion. Now, when the camera look at the part and look at this edge, it can do measurements, right? It knows the distances based on this, basically. And as you can see here, all these, they turn green. All these dots turn green. That means that the camera was able to capture them, right? So that's the first part of this process. Are there any questions? So what was the first part? To teach the system to have a sense of distances, right?
Yes.
So that's what we did right here. Now the next thing, we go to the geometry of the part, right? That we're gonna train. So you're gonna go to the tree tab. So just click on the tree, or with your, it's a touch screen, right? Then you go to the tree tab. Then while the single view inspection vision process is highlighted, you're gonna click on the new file, because I want to add a new file for the geometry pattern match, right? So you're gonna add and click on the new file. So click on the new file while the cursor is on the single view inspection vision process, and then this screen opens up, and then you can select, right? So what you're gonna select the window shift tool, right? Which is right here all the way at the bottom. So window shift tool, you're gonna select that. Once you select that, you press OK. You press OK, and automatically that window shift tool automatically is gonna bring the GPM locator tool, which is the geometry pattern match, right? And you're gonna select that GPM locator tool. This screen opens up, and that's how you can teach, basically you train the part, right? You can train the part. So the first thing you're gonna do, press the part underneath the camera, and then press snap, right? So put the part, take a picture, press snap, and basically press teach to teach the part, to teach the iRVision system about this part, right? So press teach to begin teaching the vision to find the part. Once you do that, it will show what the camera sees, because that was the snap that I took, that was the picture that I took, and I want to teach this part. I'm not going to worry about this area or this area. I want to teach this part, right? So basically you have to adjust your box again to only look at the part right here. So we adjust the box to enclose any features that you want the vision to find, and basically press OK, then you're done, right? And once you do that, that's it. All the edges are basically green now. So that means the system was able to find this edge, all these dots, these are the features of the part, right? All these edges are basically turned green. So the found edges will be outlined in green, right? So the system was able to, so when it look at the part, it look at those features of the part, right? If it doesn't have these features, it fell apart, right? Anything that is green, that means it was able to find it, right? Now, to test the system ability to find the part, all you're gonna do, press snap, and then find. So when you press snap, it takes a picture, and then you press find, it basically tries to analyze the part to see if it's the right part or not. In this case, it was the right part, and it came back with a 100% score. Usually what it does, when it takes a picture and then analyze the part, it gives it a score based on the features, right? And the score threshold, you can change that by default is 70%. That means if 70% matches with the part that we trained, pass the part, right? Find the part. So if not, then we're gonna basically fail the part. So in this case, since it was the same part, the score that it gave was 100% because it was exactly the same part, right? That we trained, right? So if you want to make the system more relaxed, you can make it 50%, right? If you make it more, then you can go to 90%, all that. So does that make sense so far? Yeah, system? Very good. Now, what if I don't want the system to look for certain edges, right? it found these edges, right? Or it found these features, but hey, I don't want to worry about these 3 dots, for example. You can mask it out, right? So there is a training mask that you can click here, edit. So once you click the training mask, this window opens up and you have some drawing tool, right? You can basically hide these edges or whatever you want to hide, right? So the system doesn't look for those features, right? As you can see here, I hit these 3 features and now they turn red. That means the system is not going to look for those anymore, right? So I don't care about these anymore, right? As long as I'm able to find these features and the outline, I'm okay, right? So, and then you press OK. Once you press OK, that's it. Now, the system is going to look for this part without these features, right? So, and then once you do that, you're basically done with your geometry pattern match, right? You're finished with geometry pattern match. The next thing is what? Do you remember? What was the next thing? To teach the distances, edge distances, right? Now that, okay, this is my part. These are the edges, these are the features. Now I want to do some measurement, right? And then I do my inspection. So you're going to go to the tree. While the first one is highlighted, your single vision inspection vision process is highlighted. You're going to select new file. And in this case, you're going to select the edge pair locator tool, right? That's when you can train the system to do some measurements, right? Edge pair locator tool. And then the edge pair locator tool will be added to the process tree, to your tree. You highlight it, you select it, this screen opens up, right? Once you have this screen, you go set. What is my search area, right? What am I trying to measure? So you press set, and then this screen, whatever the camera sees, again it shows here, and whatever you want to be your search area, you're gonna select it, right? And this is kind of small, so what I can do, I can go here, this is 50% zoom, I can make it 100% or 200%. Then it will bring up my object back here. So right now it's at 400%, so I can see my part. And you're gonna size the box to set the search area. Let's say I wanna do some measurement within this box only. I don't care about this area, right? All I wanna measure something within this box, so that's my search area, all right? And you press OK. Once you do that, then you're gonna go train. Press train to actually do some edge measurement, right? Once you press train, it will bring back your search area. Since this was my search area, it will just bring back that search area, and these are all the edges in green that it was able to find, right? Let's say I want to do measurement between this edge and this edge only, right? Between this edge of this circle and this edge of this circle, right? So I'm gonna make sure this line is from here to here, right? Train the edges for measurement and press OK when you're done, right? And bingo. Now bring back the trained edges will be displayed and it shows that it's 10 millimeters. So the distance from here to here is basically 10 millimeters. So when I put any part, not only look for the geometry, but it also look for that specific edge, right? The distance between this edge and this edge, for example, right? Should be about 10 millimeters, right? So any questions so far? So far so good? Very good. So again, to test the system's ability, all you gotta do, put a part. I put the same part. Press snap and then find, right? Once you press snap and find, it was able to basically, what it shows is 9.9 millimeters, which is close to 10 millimeters. Nothing is perfect, right? So it was able to find the part. And that edge was basically 9.9 millimeters between those two edges, right? You're gonna press next, and then you're gonna save your vision process, right? So what's the last step? The last step is to do some evaluation criteria, right? So I trained the geometry, I basically make some measurement, now I want to do the evaluation, right? To complete my vision process. So you're gonna go to the tree tab, and then the very last one comes automatically, you don't have to add anything, so no longer you have to add new file. Evaluation tool. So every vision process automatically has evaluation tool, right? So you highlight that, or you select that, and then you have this screen opens up, right? On this screen, you have two tabs, condition and variable. First, you're gonna set your variable. what is my variable that I want to evaluate, right? So you press on the variable, so you have V1, variable 1, variable 2, variable 3, and all the way. So I only want to use one variable. So V1, you're going to do drop-down menu. I want to use the edge pair that I just trained, the distance between those edges to be my variable, right? So edge pair locator tool, and the variable is basically my length, the length of those edges, right? The distance between those edges. So that's my variable. Now I'm going to go to the condition and use that variable to evaluate my part, right? So I go to the condition, and I'm going to say condition 1. There's a drop-down menu. I choose variable 1, which is the edge between those, the distance between those edges, and I want that distance to be within this distance. It's from 9 to 11 millimeters. So I know it was 10 millimeters, but I want to give my system some, room for error, right? So I'm going to say between 9 and 11 millimeters. If you find it, then it's a good part, right? If you just say 10, right, everything is going to fail because the system, nothing is perfect, right? So between 9 and 11 millimeters, and that's it. You're going to press save, next and save, and then you're done. Now you can put any part, go back and highlight the very first one, the single vision inspection vision process, to do the overall inspection of the part. So when you highlight this one, it will look for the geometry, it will look for that edge locator, right? It will look for everything, right? Press the part underneath and press snap and find, and that's it. And as you can see, this part passed because it was the same part. So it'll show the result. So this part was passed, so it doesn't matter what orientation you put it, right? It will find the part anyway, right? And this one was basically the score that it gives it was about 90%, and the distance was actually doesn't show it here, but if you scroll a little bit, it will show the distance of those that I found, right? So this part, it was undetermined. It wasn't able to make it, to find the part because probably that was a different part. Again, different part, right? It says undetermined or not evaluated. This one was the good part. It passed, right? So based on that, we can put a part and automatically either it's a good part or a bad part, right? It'll pass or fail the part. All right? Any questions that you wanna ask on this? Very good so far?
Yeah.
Now, you're able to use this inspection process in programming, right? So we can create a program and have the program to use this inspection, and based on the results, take certain actions, right? If it's a good part, do something. If it's a bad part, turn on the red light, for example, right? So you can use it in the program. So I called it a vision program. So I created a new program, vision, and then under vision, if you go under instruction, you have this vision instruction that you can use, right? So you can use vision run find. So I'm gonna say go ahead and run that inspection. You can do a choice and use inspection. So the very first line is gonna run that inspection that I just trained the system, right? And then the second line, I can do vision, get pass fail, that inspection. So what this line is doing is basically the result of that inspection is gonna put it inside that register 10, okay? And that register 10 could be 0, 1, or 2 based on pass, fail, or undetermined, right? So if it passes the system, once it does the inspection, if it passes, that register 10 is going to be 1. If it fails, it's going to be 0. And if it's undetermined, it's going to be 2, right? And I'm going to say, okay, if that register 10 is 1, that means if the system passed the part, call that program. And that program is like doing something, right? If it's 0, do something else, right? So if you don't mind, you can actually come here and then we're going to run the program right here. So let's try the system. So I'm going to have you guys come forward and look at the ball. So I have this program. It's a very basic program. This is the part that we trained, right? That's the domino that we trained. And this one should be passed, right? Because it's the exact same part, right? So I'm gonna put it under the camera. Okay, and I'm gonna run the program, right? And I'm gonna look at the register 10 as well. If it's 1, that means it passed, right? And what it does, if it's a good part, it's gonna turn on this light. If it's a bad part, it's not gonna do anything, right? So let's look at it here. gonna reset, shift forward. Let's see. Yep. For 5 seconds, and then it turns off. That's it, or maybe 3 seconds. So if it's a good part, it turn on the light. Now give me another long, something that is not 5 and 3, because it's used for those features, right?
That's good.
So maybe 3 and 3. Let's see if it finds this one. So shift forward. Nope. And register 10 now is 2. That means it's undetermined, right? It wasn't able to evaluate that part, right? Now the good thing is that domino that we just trained, it doesn't need to be in any orientation, right? It could be anywhere, right? It was able to find it, that's it, right? Even if I do it this way, it's still able to find it, right? So if I do it backward, it shouldn't find it because now it doesn't have some features, right? Nope, it was able to find it, right?
How do you set this to be dependent on the orientation of the part?
So the orientation, it automatically finds it, so you don't have to worry about the orientation.
Right, but if you wanted to pass fail based on
You
orientation.
could, exactly. So, any questions? Thank you so much. Good job.
Thank you.
Very good.